Welcome. Today's lesson is on the law of sines. The law of sines is used to find a missing side length or missing angle measure on a triangle. And you might be thinking, well, why do we need the law of sines if we've been using sine and cosine and tangent so far to find those very same things? And the reason is because the law of sines can be used even when you're not dealing with a right triangle. So this will work in a triangle of any angle measure. As a formula, law of sines looks like this. It's 3 equal ratios. The uppercase letters represent angle measures, whereas the lowercase letters represent side lengths. Side A, for instance, would be opposite angle A, across from angle A, just like the way we've been naming side lengths so far in this unit. Now, it might seem weird to have 2 equal signs in a formula. The fact of the matter is you don't need to use both equal signs. There's 3 ratios, there's 3 fractions written here, but you only need to pick 2 of them to work with at a time. What you're going to end up doing is using 2 of the 3 ratios in that formula to write a proportion. And of course, once you've written the proportion, you can cross multiply to solve. A little side note here. In some textbooks or online resources or teachers or whatever might write law of sines as lowercase a over sine of angle A equals lowercase b over sine of angle B, etc. That's fine. It really means the same thing. So if we have to use 2 of the 3 ratios in the formula in order to write our proportion, you might be asking yourself, which 2 should I use? Well, that's a good question. The answer is, frankly, it depends on what the problem is telling you about the triangle. There are certain things you're going to have to know, that you're going to have to be given in the problem in order to be able to use law of sines. The first thing they're going to have to give you is at least one angle measure, which seems kind of common sense. You can't, there's angle measures all over the formula, so you're going to need at least one of those to get the ball rolling. The other thing you're going to need, or another thing you're going to need, is the length of that angle's opposite side. And finally, you'll need at least one other piece of information about the triangle, some other angle measure or some other side length. With this information, what you'll be able to do, make a ratio out of the angle measure that you know and the length of its opposite side. Because in ratio 2, you should include the unknown value. If they're asking you for a side length, include that in ratio 2. If they're asking you for an angle measure, include that in ratio 2. Once you have your 2 ratios, set them equal to form a proportion, and of course you can solve a proportion by cross multiplying. Let's put this into action with some examples. So we are supposed to find side length that's labeled as x in this case. X, I know it's a side length because the x is on the exterior of the triangle. The vertices aren't labeled. If you really want to label them, go right ahead. It doesn't really matter what you call what. None of them are right angles anyway. But we want to start by figuring out if we're truly going to use law of sines, we're going to start by figuring out what angle we know with a corresponding side. And if you look, angle C is given to us at 73 degrees, and its corresponding side is given to us at 32.8. So we want to set up a ratio using those 2 things. Sine of C is sine 73 degrees that corresponds with length of side C, which is 32.8, and now I have my first ratio. My second ratio is supposed to include the thing I'm trying to find. Well, the thing I'm trying to find is x over here. Now x is a side length, so I need to be sure that I put that in the appropriate part of the fraction. Side lengths, I've put my first side length here on the bottom. I want to find another side length, so I'm going to put that on the bottom of my other fraction. So make sure however you commit in the first fraction, you follow through in the second. If angles are on top, stick with that throughout the problem. The angle that goes with this side, or is across from or opposite that side, is angle A, which is a 21-degree measure. So I'm going to call this sine of 21 degrees. I now have my proportions set up, and I'm ready to cross multiply. X times 73, or x times sine 73 degrees is equal to the other cross product, 32.8 sine 21. If I want to isolate the x, I could divide away, or the sine of 73 degrees from each side. So x is going to be 32.8 times sine of 21 degrees, all divided by sine of 73 degrees. Because if I divide this side by sine of 73, I just isolate the x. If I divide this side by sine of 73, I literally am just writing sine of 73 in the denominator. This is a good old-fashioned calculator problem. On your calculator, you would literally type 32.8 times sine 21, divide that by sine of 73. But if you crunch these numbers, you should get x is about 12.29155. Generally for side lengths, we'll be rounding to the nearest tenth, so I'll call that about 12.3. In this situation, we were given two angles, A and C, and a side not in between them. So that's what, I guess in terms of A's and S's, that would be two angles and a side not in between them. So if you have an AAS situation, you can solve that using law of sines. All right, on the next example, let's look at what we're given here. We're given an angle, we're given another angle, and this time we're given a side length that's in between the two. So we have an angle, another angle, and then a side in between the two. These ASA situations will also work with law of sines. Now it's a little startling at first because we're thinking, well, wait a minute, I thought we were supposed to be given an angle and its opposite length, side length. We aren't given that with D. Angle F, we don't have it there either. And then the one side length we do have, we don't know the angle that's across from it. So how are we supposed to use law of sines there? Well, it is a triangle. We do have two of the three angle measures now, D and F, so we can find angle E with a little bit of digging. If you take 180 and subtract off the two angle measures you do have, you end up with 72 degrees left over. So angle E is in fact 72 degrees, so we are given indirectly an angle and the length of its opposite side. And that is what we use to build our first ratio using law of sines. So the sine of that 72 degree angle corresponds with a length of 14.5. The way that the sine of this, see, now I'm gonna go after the x. That's what I'm trying to find. So I've got to use the angle that's across from it, or opposite. That would be angle D. So sine of 83 degrees is going to correspond with the unknown x. And from here, if we cross multiply, divide away the sine of 72. So I'm dividing away sine 72. And it's a good calculator problem again. X ends up being about 15.1. Now in the last example, the directions might look a little different. It says to solve the triangle. Well, solving the triangle just means determine the lengths of all three sides and the measures of all three angles. And frankly, that's only 6 things. You're already given 3 of those 6. So what I'm going to do, and what I recommend you would do for your answers, is I'm just going to make this table. Pretty quick table here. Once I've got all 6 of those things filled in, I have then solved the triangle. And some of them are given to me. Angle A, for instance, is a 61-degree angle. I'm going to label that with degrees. Angle B is a 51-degree angle. I'm going to label that with degrees. Angle C, it doesn't explicitly say, but I do know, again, 180 minus the other 2 is going to give me 68 degrees, so I will fill that in right now. I also know, let's see, this side 18 is across from angle C, so it is side C, is 18 or 18.0. Really all I have to do is find side A and side B and we're done here. Just like the last problem, this is another ASA problem, which means we can use law of sines, but we need to fill in that third angle, which I guess we've really already done. Angle C is 68 degrees. And that allows me to set up my proportion. If I cross multiply, I get A times sine 68 degrees equals 18 sine 61 degrees. Divide to isolate A, and it becomes a good calculator problem again, which would then round up to 17.0. I'm going to fill that in. So I'm going to go back to the sine of 68 ratio. And this time for my second ratio, if I'm trying to find side B, that is across from angle B, I'd have sine 51 over I don't know. Cross multiply, divide by sine 58 to isolate B, and crunch it on a calculator. I'm getting 16.495, which is about 16.5. All the boxes are filled in, so the question has been completed. You can use law of sines in an SSA situation where you know 2 sides and an angle not in between them. And I'm going to leave that up to your teacher to decide how far they want to venture into that area. But as far as ASA and AAS situations go, law of sines is free and clear, and we'll be looking at plenty of those problems in the very near future.